Hello friends, welcome to Edwiki Learning channel. Please do subscribe to get more updates on the DevOps concepts. This video is part of the full course AWS DevOps Practitioner training. Please do check the description below to get the link for the complete full course. Without further delay, let's get into the video. Thank you. Welcome back team, and I think start from today I'm going to resolve certain challenges that we have faced in the Docker world, or I would say I'm going to show you the exact enhancements or the benefits that we are going to get using the Kubernetes orchestration engine, right? So we have seen how the Kubernetes architecture works and how the Kubernetes cluster works with the different components, right? The different methods that are available to set up the Kubernetes and the managed Kubernetes clusters like EKS. We are deploying the EKS cluster using Terraform. Now we can just connect with the API server to manage your application deployments, right? So good. So so if you have any specific questions, do let me know, right? So if I go back to my Visual Studio Code and I can see that the EKS cluster is currently deployed, right? And I'm getting my API server endpoint as well that the AWS is provided, correct? So now I'm running the command. So the very first time, maybe I'll be keep on asking you some questions, guys, right? So tell me, guys, the EKS cluster is deployed using, or the EKS cluster is deployed using which user, right? How do you know that? Who has deployed the EKS cluster? From AWS perspective, right? So whenever you use the Terraform apply command, the Terraform is using the IAM credentials that are being set up in your system as a AWS configure, or if at all you are running the Terraform apply command on any one of the EC2 instances which is already connected with the IAM role, then probably the role credentials, something like that, right? So in my local system, since I have deployed the Terraform from my local, if I run sts get caller identity, I can see that the username called PR, right? That means what? Can I say that? Can I say that the IAM user PR is the one who has deployed the EKS cluster? Is that the right statement, guys? Right? So whenever the EKS cluster is deployed using any one of the AWS IAM credentials, right? So now in order to connect to the Kubernetes, getting me, guys? This is where we need to understand the differences between EKS and the Kubernetes, okay? So if you want to connect with the Kubernetes, you would need the AWS credential. Sorry, let me backtrack again, right? If you wanted to connect to the EKS cluster, then you would need the AWS credentials. If you wanted to connect to the Kubernetes, then you would need the API server keys, correct? Getting me, guys? If I go back here one more time, right? So if you want to connect with the EKS, right, then you need to use the AWS credentials because EKS is the AWS service. Is that good? EKS is the AWS service which is facilitating the managed Kubernetes services for you, right? So anything that you wanted to deal with EKS, right? Anything that you wanted to deal with EKS, then you need to use the AWS credentials like IAM role or IAM user. Then you run the commands called AWS EKS commands. But to connect with the Kubernetes, that means you are exactly connecting to the API server component of your control plane, right? So for that, you would need the API server credentials. What are the API server credentials? The API server credentials will be the keys that we need to set up, like the security certificates, right? That we need to use to connect with the API server endpoint. Are we good with this? Right? When you deploy the EKS cluster using any one of the AWS credentials, right? So now you would need the API server, you would need the Kubernetes server certificates to connect with the Kubernetes, right? How do you get that Kubernetes certificates? You need to ask the EKS case, because EKS is the service that is facilitating to deploy the managed Kubernetes. Then the EKS might be knowing the keys that they have used to set up the Kubernetes, correct? The the server side keys or the client side keys, all the keys might have been right available with the EKS. That means the AWS is having the information which keys that they have used to set up the Kubernetes cluster, correct? Hence the reason now, to connect to the API server endpoint, you need to get the certificates first, right? Which we are calling it as a Kubernetes configuration file or kubeconfig file, right? So now to get that certificates, you need to ask the AWS EKS service only, and that is where you need to run the command called AWS EKS, right? Update hyphen kubeconfig hyphen name, and specify the EKS server name, and specify the region in which region this EKS cluster is currently running. So when you run this command, the AWS EKS command is now authenticating to the EKS service using the IAM credentials that are currently set up, right? Then the EKS will be replying back to you saying, hey, these are the certificates that you need to use to connect to this particular, this particular, I would say the Kubernetes API server endpoint, right? This command is automatically populating the kubeconfig file in the default location called .kube/config location, and that will be picked up when you are using the kubectl command line. So kubectl, let's say, get nodes to see the number of nodes that are there in this Kubernetes cluster. Now a question for you at this time: to run the kubectl command, do you need the AWS access key, secret access key? To run a Kubernetes kubectl command, do you need the AWS credentials? Not really, right? You don't need to. As long as if you have the kubeconfig file, if you have this file, that is good enough to connect with the Kubernetes and start managing your application deployments and the configurations. So anything related to the Kubernetes, you will be using the kubectl command line concept. Now, so the AWS EKS command is being executed by the PR user, correct? In this case, because when you run AWS EKS command, right, this command is being authenticated by the AWS credentials only to connect to the EKS to get this keys are generated, correct? So in your AWS account, there are multiple IAM users, right? Can be right. Your AWS account may have multiple IAM users, right? So any user can run this command, correct? Pretty much. Any IAM user can run this command in order to generate the kubeconfig file, isn't it? Not really. Let's say as of now, I'm running the AWS EKS command as a PR IAM user. Let's say you also having the IAM account created in the same AWS account, right? Then you also can run the AWS EKS update hyphen kubeconfig command from your IAM credentials, isn't it? Obviously, right? We can do that, because to run the AWS EKS command, all you would need is you just need an access to the EKS. Probably the IAM user that you are using to run this AWS EKS command, that user should have a permission, should have a policy attached that policy should give you the EKS permission. That's it. Then you also can run the AWS EKS update -kubeconfig and can generate a kubeconfig file out of it. Correct? Technically, that's possible, right? Well, if that is the case, and of course, yes, every IAM user, right? Every IAM user, whoever having an account in this AWS account, can definitely generate a kubeconfig file by yourself, as long as you have the policy attached saying that the EKS can be accessible. But the kubeconfig file that is getting generated, right? That config should be accepted by your Kubernetes, correct? The AWS, what is the role of AWS? AWS EKS command is just generating the required credentials or generating the required, security key file, like I mean to say kubeconfig file, right? Whether the Kubernetes will accept the connection or not, it's all up to the Kubernetes, correct? Hope you are getting me. That's where you need to understand the difference between EKS and the Kubernetes here, guys. I'm not trying to make you confused, but I'm trying to make it clear here, right? The AWS EKS command is just generating the kubeconfig file that is associated to your Kubernetes cluster. Later point, whether your Kubernetes will accept the connection or not, correct? When you use the kubectl command, right, by using this generated kubeconfig file, right? If you run a kubectl command by using this kubeconfig file, right, the request will be going to whom? The request is going to the API server. The API server will accept the connection or not. That is something related to the Kubernetes, right? Not AWS one. Getting me? So the way how it works as of today, right? Which IAM user has deployed the EKS cluster? If that IAM user creating a kubeconfig file, then that kubeconfig file will be working. Then the kubectl command line will be working to authenticate to the API server to get a response. If any other IAM users are generating the kubeconfig file, your kubeconfig file may be getting generated, but your API server will be rejecting that request. It will not be authenticated. Is mean that what? So initially, the very first time when you deploy the EKS cluster, the kubeconfig file has to be generated from the same IAM user which was used to deploy the EKS cluster. If you are generating the kubeconfig from any different IAM user, the kubeconfig may be getting created, but your kubectl command will be not working because your API server will be, will not allow to authenticate using the kubeconfig that is generated by a different IAM user than what the IAM user used to deploy the cluster. Is that clear? Of course, we can make a configuration changes. Of course, we can do some customization to give the access to all the other IAM accounts as well. But I'm telling the default behavior, right? By default, right? By default, right? The kubeconfig that is generated by the IAM user, which should be the same what is being deployed the EKS cluster. Then only it works, or else it will not work. How to give the access to other IAM users as well? We'll see in later sessions for now. Of course, you are not sharing the IAM credentials with anyone, right? How to give the access to other IAM users is possible. We need to do some more customization. So on top of that, we'll do that granting the Kubernetes access to different IAM users in a later part.
Hey, Pierre, I have a question.
Yes, please.
So let's say in an IAM, you create a group, okay? And in that group, there are two users, user A and user B. And both the users has full admin access. Now, user A creates that EKS cluster using Terraform. And after that, his shift ends and he goes back. and user B comes and he starts running that kubeconfig file, whatever the command was. I forgot. It was some EKS update kubeconfig hyphen name. So you mean to say that it will not work if user B tries to create that config file and then start executing the API commands like the Kubernetes commands. It's not going to work.
Yes,
That is,
yes.
but both have got admin rights. They
You
are
have
the both.
got the yeah. You have got the admin permissions to the AWS services, not for the Kubernetes. That's where we need to understand the difference between EKS and the Kubernetes. EKS is the AWS service where you have the admin permission. That is the reason both accounts are able to generate the kubeconfig, but is not mean that the API server will allow the connection. The API server is the Kubernetes concept. The API server is not a AWS service. API server is the Kubernetes service, which is running as a one of the service inside a control plane EC2 server, which is nowhere related to your EKS, right? EKS is just facilitating the managed Kubernetes in the sense the EKS is the service which will help us to install, set up the Kubernetes software on these EC2 instances and make the things working for you, and which is facilitating some abstracted layer of some benefits to make your life easier. So if you have the admin access, you are saying that you are having the admin access to the AWS, and that will help you to generate the kube config. But your API server is accepting the connection or not. So the API server will accept the connection only from the IAM user, only if the kube config is generated from the IAM user where the cluster is created at initially. Later, yes, if my IAM user B should able to connect API server, yes, it is possible, but we need to do some customization. We'll talk about that customization later. Yes, initially when the cluster is being deployed, right? Initially when the cluster is being deployed, right? That time, yes, the EKS will try to tell to API server that, right? Initially when you deploy the cluster, right, the EKS layer, right, it will tell to API server that, hey, this cluster is deployed using so and so on IAM user. Please allow this IAM user to connect to the API server services. That is how it will do the setup automatically. That's the reason if the kube config is generated by that IAM user, then only it will be allowing the connection, or else no. Why it is accepting the configuration? Because the first time when you deploy, there should be a way to connect it to the API server, right? That's the reason it will try to do some setup, do some configuration in a Kubernetes level, in a API server level, saying that, hey, PR is the IAM user that is created a cluster. You please allow the kube config, which is created by the PR user. Then that's the reason you can log in with the same. Then you can do whatever you wanted to later to add any other multiple IAM users if you wanted to grant an access. Are we good with that? This is early to talk about the configuration, how to give the access to the other IAM users, all these things. We'll talk about that later. The reason why I'm bringing this topic now, because if you are setting up the cluster, you may be end up having the issues in connecting to the API server. That's the reason I'm just giving this context. So for now, create a kube config using the same IAM user which you have used to deploy the cluster. Don't use any IAM user. We'll talk about that piece later. Now, once the cluster is deployed, right, now our goal is to run our application, right, running in the EKS cluster, right? So from now onwards, I will be using the kubectl commands only to connect to my Kubernetes API server endpoint to deal with my Kubernetes related operations. right? So the first command is kubectl get nodes command to see the list of nodes available in the cluster, right? Now let me run kubectl, yeah, kubectl run command in order to create a pod. Let's say kubectl run the pod name hyphen image, specify the image name. By default, it is trying to pull a image from the Docker Hub registry. If you are not specifying, the image has to be pulled from which location, right? And this command will ensure that the pod is being deployed. Correct, no? When I'm at a Kubernetes level, always we will be deploying the pod. Inside the pod, there is a container. Inside the container, there is application. That's how the overall hierarchy will be there, right? Now let me maximize the screen. Let me clear the screen. kubectl get pods is the command to see the list of pods that are currently running on my Kubernetes cluster with the status, right? The ready column is saying that, right, uh, in this pod, how many containers are there and how many containers are currently in the ready state. You got me what I'm trying to? If it says one by one, is mean that in this pod total there is one container and that container is currently a ready state and it is currently listening to the application port number. So tell me guys, inside a container, right, how many number of containers can be possible? Or inside a pod, do you think can we have multiple containers? Right? Maybe that's a question that we need to look at now, right? So in general, right, if I go and talk about the pod, what is pod exactly, right? So in your worker node, there is a container runtime who is responsible to create a container whenever the request is made by your kubelet service who is receiving the instructions from the API server, right? But as we all know that the containers cannot be running as a alone when it comes to the Kubernetes orchestration engine. Hence the reason there will be a pod which is kind of a wrapper on top of the container, right? So that the Kubernetes is always managing your application as a pod layer, right? That's what we have seen so far. That's the reason from the Kubernetes perspective, the pod is the actual execution unit, or I would say pod is the actual compute environment where your application will be running, right? So the container properties, the the containers that are running inside a pod, right? The container properties will now become the pod properties. In the sense, the IP address that is assigned for the container, that IP will now become the pod IP address. That's how it works, right? Most of the container properties will now become the pod properties, and the Kubernetes will get to see that pod and identify the pod and manage the containers. That's the technical part, how the Kubernetes is handling the things. It is possible to have multiple containers running in a single pod as well. Remember, in general, inside a container, you need to run only one application, right? Inside a container, you need to run only one application. But now, when it comes to the pod wrapper or when it comes to the pod layer, right? It is possible to keep multiple containers inside a single pod. I'm saying it is possible, but as much as possible, try to avoid that. Keep only one container inside a pod just to make it more better and better. But sometimes there will be a requirement where we need to keep multiple containers inside a pod as well. How many containers are there inside a pod? That many number of applications are actually running in, correct? Because each container is running with one application, right? If I have total 3 containers inside a pod, then there will be 3 applications running inside a single pod, right? But whenever you are planning to have multiple containers to be running in the single pod, you should always ensure that only one container should be having a main application. The other two containers should be having a secondary application, which we are calling it as a supporting application. Technically speaking, the other containers should be running a sidecar application or init application. That's the technical term that we use here. What is the sidecar container or what is the init container, right? So let's say I have I have three containers that are currently running inside a single pod. Okay, one container is having your Apache HTTP web server application, right? One container is having a Apache web server application, which is the main application which is running, right, to serve a web page. The other two containers are the sidecar containers. That means the application that is running in the another container may be doing the job of collecting the log files, uploading the log files to the S3. Getting me, guys? The application that is running in the second container may be doing the supporting work, right? To get the log file, uploading the log file to S3, uploading the log file to different places wherever I wanted to. Maybe I need to filter the log data, and if any errors are there in the log, maybe I need to trigger a announcement, right? That kind of the supporting job will be done by applications running in the sidecar containers. You should never ever run all the main applications in all the containers of a single pod. Always there is only one main application. The other two are just the supporting containers to give some help to the main application, like as I said some time back, right? Processing the log data of your web application.
So then what would be the IP of the pod if there are 3 containers running?
As the Kubernetes is trying to identify the pod when it comes to the Kubernetes world, right? Your pod will have an IP address. Your containers will not be having any IP addresses in this time, right? So of course, there is a IP for your container when it comes to a native Docker concept, right? But when it comes to the Kubernetes, your pod will get an IP. That IP will help the Kubernetes to identify the pod. Inside the pod, your containers are not assigned with any IP. Your containers are assigned or isolated with your application stack and are dedicated to run your application only. For now, we will see how to run a pod with one container, which is your main application. We'll see how to keep the few other sidecar containers doing some supporting job at a later time, not to confuse or not to make it more complex by introducing all this stuff today itself, right? But it will be a basic to understand that it is possible to have multiple containers inside a pod, but one is the main application, the remaining are a kind of the initialization or the sidecar applications which will be doing some supporting work to the main application, and it has only one IP, and the containers does not have any IP because the container need not to have an IP. Why? When it comes to the communication, right? The communication all happening between the pod to the pod. Only the pod will have an IP in terms of the network communication that the Kubernetes is handling, right? So that is the reason. Now, if I come to my kubectl get pods command, that is what it is telling that, hey, This pod has one container inside, and that container is currently in the ready state. That what the one by one state says. Currently the status is running. The application or the container is not restarted anymore. It is deployed 30 seconds ago. Right now, how did I deploy this application, guys, or container? I'm at a pod. I just have ran a command called kubectl run command, right? Which is like equivalent to your Docker run command to run an application. So far, so good. You can run the same get pods command by giving -o void flag, which will be giving some extended information, which will tell that the pod is currently running on which worker node. You can see the worker node name over there. So this is the default naming convention of AWS given for your EC2 instances. That's the reason we can see this name over there. And you can also see the IP address that is currently configured for your pod. Of course, even here, you will never ever use the IP address of a pod for any of the communication, right? But just to get the context, yes, the pod will have an IP, but we will never use the IP address for any of the communications because the pod will keep on the IP will be keep on changing as and when the pod gets stopped and restarted. Sorry, pod gets terminated and restarting a new pod out of it. So we will not be relying on the IP address anymore. So let me try to see if I go inside. So the kubectl exec, right, and as an interactive mode, and let me specify my pod name, right, and I wanted to run a command called bash. All right. So this is okay. I'm getting some error because I'm actually using the Windows system and it is not right. It is not having an. Let me see the things. Yeah, it's working. So somehow the bash is not working. So I need to see if the image that I have used is having the bash. But it's to get started with, right. You see here the kubectl exec is now executed. What is the equivalent command, guys, in general? The docker exec, right, to run the commands inside a container. So the same thing now here I'm using the kubectl exec to run the command inside your pod. When I say run this ls command inside a pod, where it is getting executed, guys? Is it running in the pod or is it running in the container which is inside a pod? Technically, you are telling that my ls command has to be executed inside a pod. You are just specifying the pod name here. But do you think the commands can be executed inside a pod from technical concept perspective? No, right? The pod is just a layer. Inside the pod, there is a container. Inside the container, all these commands will be get executed. Since there is only one container inside the pod, it automatically take care of running your command on that pod only. Sorry, on that container only. If you have multiple containers, then you need to choose your command has to be get executed in the which container exactly. We'll see that flags later whenever we get multiple containers inside a pod. But this is the command how you can run the commands inside your pod or inside your containers. Kubectl logs and specify the pod name. So this is the command to see the log data of your pod. Same thing. Previously, I was using the docker logs command to see the logs of a container. now I'm using kubectl logs command to see the logs of a pod. In the sense what? It automatically give you the logs of the container that is currently running inside a pod only. But you always work at a pod level. The Kubernetes will take care of right, making the things happening at your container level internally. Are we good with this? kubectl describe is the command to see the properties of a pod, how the pod is configured. The describe pod and give the pod name, and which is the equivalent command is docker inspect command. We know the docker inspect, right, which will be giving you the characteristics of your container. The same thing now I'm using kubectl describe. It will give you more details about the pod, how the pod is being created. This is giving you the information like what is the pod name, and you can see the pod is currently running on which worker node, when the pod is actually started, right? And the pod IP address, right? And you can see that the container section, this is where it is telling that inside the pod there is a container. The container name is also same as pod, that's the default nature, right? So now you can see that the container ID is here, right? And the container is created using which image, right? And you can see that the container is started on so timestamp, right? The container status is running, and you can see some kind of this is fine, right? Yeah, this is all about your container, guys, right? Makes sense, right? Now it is more clear to understand that, right, inside the pod there are some containers, and it is showing the details of all the containers with the container ID as well. Because at the end of the day, this is all about your container concept only, nothing new. We are just putting the orchestration layer on top of your containerization concept, right? So at below you see that the event section, this is little important to know that, right? The event section will give you more details about how your pod is getting created and running as an application, right? For any reason, if your pod is not able to create, pod is having some trouble to bring up the application or a container, you'll get to know the reason why it is not working at this event section only, right? So in the event section, if you closely observe, right, what's happening, right? So the moment when you deploy the pod, the scheduler service is actually taking care of scheduling your pod into a specific worker node. That is the first step that it is doing, correct? Once the scheduler service is identifying that the worker node where the application has to be running, then you know, right, the API server will go and inform to the worker node, hey, please go and run the application, right? That is where you can see that the kubelet, right, the kubelet is now taking the responsibility to run this application on the specified worker node where it got finalized by my scheduler service. Now that's where you can see that the kubelet is now managing to pull a image from the Docker Hub registries. Once the image is successfully pulled, then you see that it is, you know, creating a container for you. Then your container is getting started. So finally the container is up and running, in the sense your pod is actually up and running, right? So you should not ask me more details like why kubelet is showing here, why the container runtime is not there, because this is the Kubernetes concept, right? The Kubernetes will not give you the details of the container runtime. That is a completely a low level concept, right? So this is all giving you only a Kubernetes resources which are, you know, playing the game to manage this whole workflow of the pod creation process. So if any issues in the process of creating a pod, you'll get to know the reason, right, in this event section for troubleshooting per se. Now kubectl get pods to see the pods that are currently running. I have my Apache web server application running in this kubectl, right? Uh, delete pod, specify the pod name. This is the command to delete a pod. It's like a docker rm command, correct? Now you see that there are no pods. Good. Now how do you create a pod again? So we need to run a kubectl run command, right? But
So,
kubectl, go ahead please.
sorry. Do I have any control where in which container I can create a pod?
Mhm. So definitely I'll be doing more enhancement on this process, right? We'll get to know, right? The container will be inside a pod, right? Not like pod will be inside a container, right? And
I,
oh,
I didn't say in the container. I said, do I have a control in which worker node we can spin up a pod?
well, so answering to that question, right? The answer is being given yesterday, saying that it is possible to override the scheduling. It will happen after 2 3 days of time. It's a little advanced to go to that level, or it's not easy as well to give you the answer right away. So there is a specific section to handle that scheduling policies. Right, but definitely all this definitely be covered. I'm just going in a step-by-step process, right? I'm not jumping now. Running the kubectl run command is not a recommended way. Of course you guys can keep on asking me the questions. It's my call to give the answer or park it for future based on the situation, right? uh, Running the kubectl run command is not a best practice. Why? Because, right, so today I'm giving just a pod name and the image name. Tomorrow I may need to give more controls as you have been asked just now, right? Maybe now here I'm saying that, hey, please create a container, right? Using the HTTPD image. So simple, right? But here I'm telling that, hey, my image has to be deployed as a pod. That's it. So simple. But now tomorrow I wanted to tell to my Kubernetes that my application should be deployed by following the high availability, by following the auto scalability. Please do the health checking. Please schedule my pod into a specific worker node which I'm looking for. Don't take a default choice. And my pod should have this much of processor and memory capacity. You got me what I'm trying to. We came to the Kubernetes world to have all these benefits, right? All these advantages. How will you tell all these advantages to the Kubernetes? Because Kubernetes is not going to apply all these features just like that by default. No, you need to tell that, hey, I need all these features to be applied for my application. If you wanted to tell all these, you need to inform in your Kubernetes command line, correct? Because kubectl is the only way to go and talk to the API server and pass your information. So it's very difficult to give all these inputs as a flag based, correct? Your command will go very lengthy basically. Agree with me? By giving all these inputs. Hence the reason it's not recommended to use the kubectl command line, being said that it's very crazy to give all these best practices, right? So there is a other way to manage your application deployments and the operations. Of course, everything whatever I do using the second approach can be done from kubectl command line as well, but which is little tricky to, right, handle some complex scenarios. What is the second way of deploying your applications, right? So Whenever you wanted to deploy a pod in the Kubernetes cluster, as usual, I need to talk to the API server. The API server will take care of running the pod in your worker nodes, right? So to talk to the API server, you define your requirements in a configuration file. Getting me? Sometime back, I given my requirements using the kubectl run command, right? Now, rather going to that method, I'm going to put my requirements in a configuration file. In the configuration file, you define what is that you are looking for. Hey, I need a pod using so and so image, right? Please make it happen. So that requirement, you convert it into a configuration file. Then you give this configuration file to the API server. The API server will read this file, understand the file, then accordingly it is going to deploy your application it into your worker nodes. The configuration file that I'm referring here is technically called as a manifest. This is called as a Kubernetes manifest file, which you have defined with the instruction that you are expecting the API server to do your application deployments or any configuration. All the Kubernetes story that I'm talking about here is after the image is created. All the Kubernetes story that I'm talking is the orchestration tool, which is on top of the image, right? And the sense once the image is ready, once the image is there with you, how I'm going to deploy the image into a Kubernetes with all the best practices. That is the story that we are talking about, correct? That means by the time you come to the Kubernetes, your image is already prepared. How did you prepare the image? You prepare the image using the Docker file, correct? You have already written a Docker file, you execute the Docker file, the image is created. Now the next part is how I'm going to run my image. That is where now the Kubernetes is coming into the picture. Is mean that now answering to the question in the chat window, I'm not going to replace my Docker file. The Docker file is a mandatory, it is always be there. No matter you are running the application in a Kubernetes or you are running the application in a general Docker native concept, no matter, your Docker file is always be there. I'm not replacing that. That is just to create image. After that, how I'm running the application is the matter. Now, coming back to the Kubernetes manifest file, right? The Kubernetes manifest file, right, has a specific syntax that you need to follow. The Kubernetes says that, hey, I have a specific syntax that you should follow and follow the method and write your instructions. Then API server will understand it and proceed for the deployment. Any configuration will have its own syntax, right? In general, correct? Like Docker file has its own syntax, right? In the same way, the Kubernetes has their own syntax. This syntax is called as a YAML syntax, YAML. YAML is the declarative language. YAML is the declarative language. The Kubernetes is following the YAML declarative syntax to compose the manifest files. The YAML declarative syntax is very easy since that is just a declarative language in the sense any data, any input that you wanted to give, you just keep it as a key value pair. That's it. That is called as YAML. You see here API version colon value, kind colon value, metadata colon value, something like that, right? So this is just a key value pair kind of. So simple YAML syntax, right? So when you are writing the manifest file, any manifest file will have a standard concept. The left side, you all know, right? The left side is mostly standard keywords. The right side is your value, correct? The API version kind metadata spec. These four are the pretty much mandatory keywords that you need to use in your manifest file. The right side, now you take a decision what kind of the value that you wanted to keep on. If I go for the second line here, the second line will says that kind, right? That means what is that you wanted to create by the API server? That is what you need to inform in the second line. Let's say my expectation is I wanted to create a pod. Then you tell that POD pod. That means, hey, I want to create a pod. That's called as a kind, right? Now you see the spec section. Under the spec section, now we need to tell, right, the specification about a pod that you are going to create. What kind of the specification, guys? My pod has to be created, right, using so and so image, right? You see under the spec, under the containers, right, I'm specifying that, hey, httpd is the image that you need to use, and create a container. The name of the container is httpd hyphen container, whatever the name that you like it. Like that, you are defining the specification of a container that should be part of this particular pod. That is how the whole manifest file will be there. Under the metadata, you can define the name of the pod. You see, metadata in the sense what? Metadata is the general name, sorry, general properties that you need to give to your pod, right? So under the metadata, usually you give the name of the pod that you are creating. You can give the labels to your pod. Basically, in the Kubernetes world, the labels are a kind of the tags. How many of you know what is it mean by the tags when it comes to the AWS EC2, right? The tags are why we are using the tags over there. The tag will help us to identify the server, correct? Whenever you give the tag, that helps to identify the server. Hey, please list all the servers which are having this particular tag, right? Something like this. So the tags are just for identifying the server and for that per se. Similarly, Kubernetes using the concept called labels. Under the labels, you can define whatever the label that you like it. There is no hard rule. Under the labels are like a key value pair, like how the tags were a key value pair in the AWS. Here also the labels are key value pair. Anything can be a key, anything can be a value. It's up to you. Because tomorrow, if I have some 100 pods running in my Kubernetes cluster, let's say I wanted to go and filter some of the pods. Got me? How do you get some filtering the pods? Maybe through labels, right? For that purpose, the Kubernetes will come up with the concept called labeling, and you define whatever the labels that you like it to identify the pod tomorrow in order to filter, right? Or whatever it is. That's it. That is my manifest file to deploy a simple pod. So that pod section, whatever is there, right? That pod section will be helping the API server to create a pod. Whatever you have said, the container section, that will help to create a container. Sorry. So finally, when you use this manifest file, that will be get deployed a pod, inside the pod, a container. That's cool. Why we are using this kind of a manifest file, as I said, right? So tomorrow I wanted to tell to my API server that, hey, please give me the high availability, load balancing, maybe health checking. I wanted to enhance my deployment with all these benefits. So it's very easy to put that instructions in a manifest file format by following the syntaxes. Now, anything that you are creating inside a Kubernetes is called as a resource from Kubernetes perspective, right? From Kubernetes perspective, anything that you are asking the Kubernetes, hey, please go and create this. What is that? It is just a resource. That means, let's say, when I'm asking my API server, hey, please go and create a pod. What is pod? Pod is treated as a resource from the Kubernetes perspective. Are we good with this? Pod is actually a resource for Kubernetes. For that matter, from the Kubernetes perspective, pod is a resource. Even your worker nodes are the resources, right? Everything, whatever is there in the Kubernetes, right? Everything is treated as a resource kind of from the API server language perspective. Why I'm giving this instruction is, right? So whenever you are defining the kind in the second line, that is where you need to specify the resource type. Are we good with this now? What kind of the resource that you are looking for? That's how we need to question ourselves, right? The Kubernetes will ask you, hey, what kind of the resource that you are looking for? Hey, I need a pod resource. Got me? That's how the term will go. So in the second line, you need to specify the resource kind, which resource that you are looking for, and I want to, have a pod resource and specify pod over there. The API version, the first line, right, that will give you which version that it has to use. So at the moment, don't worry about what is V1. Go with a hard-coded understanding, right? We'll see better clarity about the V1 because to exactly understanding the V1, right, you need a concept called API. As of now, I did not introduce you what is API. So let me make it as blinded, hard-coded for now. We'll talk about later. But anyway, how do I know that I need to write the manifest file like this? Because all what I know is I wanted to create a pod, but how to write this manifest file, correct? So as usual, we need to ask Kubernetes. Kubernetes API reference guide. So there is a documentation. Right. So there's a documentation here in the left side. You can see the different number of the 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 resources. Right. We need to go and see what is that you wanted to create in the Kubernetes. Probably I wanted to create a pod. Do we have the example for pod? I wanted to search again. Yeah, here we go. Right. You see here pod v1 core, some example is there, and this is where it will tell you guys same like how we did some struggle to understand Terraform documentation, then Boto3 documentation. Now I'm coming to Kubernetes documentation. It will help us how we can write a file. Okay, so it tells that to create a pod using the manifest file, follow the syntaxes. API version is the key, kind, metadata, spec, and what will be the value for each and every keyword. The value can be a string or could be can be any other, right? So by looking into this documentation, now we need to see how to frame the syntax. Now don't worry about all these, but for now let me go to this example. You see, you got one ready-made example. Now it's very easy, right? So this documentation says that if you want to create a resource called pod, always your API version is v1. That's what you can see here. If the kind is pod, if you want to create a pod, your API version value is v1. That's what you get it from documentation, right? So go with the same. just make it as API version :v1 because the documentation says that. Now the kind, I wanted to create a pod. Under the metadata, you specify the name of the pod. Under the spec, specify container : then you give the name of the container. I mean to say name of the container, which image that it has to use to create a container, and if you wanted to do any more things related to container, you can do all of this configuration there. That's how it works. This is called as a YAML syntax. Where it's going? I just back here. I think my web page is not good. Let me copy this syntax. I'll keep it in my Visual Studio Code, right? So whenever you are writing the manifest file by following the YAML syntax, right? You create a file. The name of the file can be anything that you like it. The file extension should be YAML. Now you keep your manifest definition like this. I'm just going with a very simple, right? The YAML is very easy. It says that the key : value, right? Key : value, key : value, so on, so on, so on, so on, right? So there are only, I think, only two type of data types that we need to work on here, right? If your value is a string, right? If your value is a string, then it's very easy. Key : value, and the value will be a string. Sometimes the value can be a list. Whenever the value is a list, then it should start with a hyphen. Hyphen, then you specify your information here. That is called as a list format, right? And that's one thing. The second thing, the indentation, the spacing, right? How would it understand that the name : pod hyphen example, this particular line is belonging into which category or belonging into which keyword, right? It has to understand that, right? That is where you give the indentation here. Then it understands that name : pod hyphen example, this particular line is belonging into the metadata section. The container and the below two lines, all these are actually belonging into the spec section because you maintained a space over there. Make sense? So most of the times you are actually copy paste your manifest file. You don't need to worry too much in how to write it from scratch, but we need to understand the indentations correctly. For example, if you do like this, it will not work. Why? Why? Now it will not understand that the name : pod hyphen example, this line is belonging into the metadata. It will not work for this. So if you give the space over there, then it understands that this is the information related to the metadata. That's how it works. So the indentation is always, uh, always plays a major important role here. YAML is the declarative syntax. When I say declarative syntax, like how the Terraform has its own syntax, how the Python will have their own syntax, right? The YAML has its own syntax. in terms of giving the input, right? Always the input that you wanted to give can be a list format, can be a dictionary format, can be a integer format, can be a string format. Agree with me? Usually these are the topmost different type of the data that you wanted to give, right? So when you are giving this type of the data to your program, right? So how can I give the string? How can I give the list? How can I put a dictionary? That is what is a matter, and the syntax will vary. So here you can see the AML syntax, which will tell you how to give the data in the list and the dictionary formats, right? So anything that you wanted to give as a list, you need to give it using the hyphen, guys. You see, hyphen space and specify your item, hyphen space specify your item, hyphen space specify your item. This is called as a list format in the AML. Nothing new actually. So this data, right? This data, just to come here, how will you specify the list items in a Python? You specify a brackets and specify the value, something like this, right? Maybe it could be the same even if it is in a Terraform as well, right? So the same, the list of items that you wanted to specify, you are putting it in the hyphen and then the element, hyphen element, hyphen element. This is the format that we use in the AML to specify the list of items. That's it. Just a representation is little different, right? Now, if you wanted to give a dictionary, which is the key value pair, and this is how it works, right? So key colon value. When it has a multiple values, then you maintain the indentation like this. You see the indentation here. The Martin is the dictionary key. It has a value. The value is again a dictionary. Again, because I can see a key and the value here again, and I'm maintaining the spaces there. How will you put this information in the other languages? Let's say Python or Terraform. So basically it will be like this, right? We have a dictionary. I have a Martin is the key. Sorry, Martin is the key and it has a value. The value is again a dictionary, right? As per this. So the value is again a dictionary. Inside that, the key is a name and the value is, let's say, Martin. I'm just showing some example. Comma, it has a one more key, job, and it has a value called developer. Getting me, guys? Right? So this is a dictionary containing a sub dictionary inside, but the representation is little different. That's it. And that's where we need to maintain the indentation here. Maybe in Python and other languages, we are using this brackets in order to differentiate the things. Here we are using the spaces to differentiate the things. That's only the difference. And these are the only two data types that we use in AML. One is the dictionary, one is the list. That's it. You are not using any other things. So it's very easy. You will get to know as and when I'm moving further. Now let me write a simple manifest file because I wanted to deploy a pod. Believe me. Now onwards, Kubernetes, the whole concept will be relying on the manifest file only. If you ask me, is it mandatory to know manifest files? Yes, right? The Kubernetes whole story is depending on the manifest file only. Nothing else can be done. Now, let me write a simple manifest file to deploy my pod, right? So to deploy the pod, to get started with the manifest file, so first you need to specify the API version. So which API version that you wanted to use, and as per the documentation, because if I go to the documentation says that to create a pod, the API version is always v1, and let me maintain the same here. And believe me, API is lowercase, V is uppercase, then the version. That's a standard. We need to follow this camel case exactly. Done. The next line will be kind. These are the standard, right? And what kind of the resource that you are looking for? I want a pod. And again, P is the uppercase. If you make it as lowercase, it will not work. Then I wanted to specify the metadata information of my pod, because I'm trying to give the details about the metadata. If you have multiple information, it can be a one more space and specify the name of the metadata. This is my web pod. That's the name of the pod. And under the metadata, you can specify the labels, right? And you specify the indentation again and specify the key value pair. For example, created by, for example, environment. Let's say I wanted to deploy this into a dev environment. Of course, initially, how do you know all this? We need to get into the documentation. It will explain you. You see, metadata. Under the metadata, how can I give the information? Go to this here and it will help you how to write a metadata information. And we need to follow all these things. But if you can write one manifest file, pretty much same for everywhere. So we don't need to worry too much in going to the documentation again and again. After the metadata, I need to specify the spec. You see guys, again I'm going with the line 0. Why? This whole part is under the metadata. I maintain the space accordingly. The line number 6 and 7 are related to the labels, right? The line number 4 and 5 are related to the metadata. That's how I'm maintaining the indentation here. Now you specify the spec, which is the specification of the pod, how it has to be. Now under the spec, I wanted to specify the containers, how my containers can be created. You can get that here. Containers, right? Colon. I think previously I was saying like a pod can contain multiple containers, right? That's a possible. So can I use the statement like a pod can contain a list of multiple containers or list of containers, right? That is where you need to understand that it will start with hyphen. This is the first container. Name of the container, right? And specify the image, which image that you would like to use to create a container. My manifest file is ready. That's it. My manifest file is ready. Now all what you need to do is run this manifest file. So kubectl get pods. You see that there are no pods that are currently running so far. Now in order to deploy a pod, kubectl apply -f and specify the file name. I'm in the different location. Let me come back to the location. Yeah, kubectl apply -f. Let me specify the file name. That's it. Hit enter. Now what will happen? It will just take this file as an input. That file will be given to the API server. API server will understand this file and it will be processing your file, and accordingly the resources will be getting deployed in your Kubernetes cluster. You see now, it's the same thing. kubectl get pod, your pod is deployed. Done. That is how we need to write a manifest file, guys. One good thing here is any manifest file that you are writing, it is always a standard API server kind metadata spec. This is standard, guys, right? You just need to change this. Should I use v1? Should I use pod or something else, right? Should I use which image? These things will be keep changing. The left side things are almost pretty standard. Initially you may feel little difficult, but since it is a standard template everywhere, right, it's gonna be little simple down the line. Cool. Now anyway, we'll definitely keep on doing the improvements how we can write a manifest file efficiently. For now, we'll take a break there. Now anyway, my application is running as a pod. How can we access this application from my external browser? Maybe I wanted to access a website from my browser. How to access this pod which is running inside inside a Kubernetes, one of the worker node. Are we good with this to get into the step to access the application now? Because inside this, it is currently running your Apache web server. Not really. I already said, right? The Kubernetes is the heavier concept. It's all logical concept that we need to put some effort to understand it. Anyway, I'm going to solve all those puzzles. Now let's see how to access the application. Maybe the question for you at this time: how will you be accessing the application that is running inside a container when we are running the container and a native Docker concept? Port mapping, right? Here also I'm doing the same, nothing new. Again, I'm doing the port mapping but in a different way, right? Because at the end of the day, my application is running inside a container only, right? Even it is a Kubernetes, it's running in a container only. So more or less the concepts are same, but the Kubernetes is making it in a different way. That's it. The Kubernetes is giving you a NodePort service, right? We call it as a service. The Kubernetes is giving a service resource which will be helping us to access a application running inside a pod, like how you are using the port mapping to access the application previously. Same thing here, we are using a Kubernetes service type NodePort to access the application. That's it. We'll see how this is gonna be working. The only difference is previously my container was running in one server only. You are able to do a port map and just access it. But now you have multiple worker nodes in your Kubernetes cluster. Each worker node has its own IP address, which is a EC2 IP address, correct? The 172 that I'm specifying here, which is the EC2 IP, right? Because each EC2 server is a worker node. Each worker node has its own IP. Good. Now, when you deploy a pod, right? When you deploy the pod may come up in any worker node, correct? You tell to API server that, hey, please create a pod. Your pod may be get created in any worker node that the scheduler service is taking a decision by default so far. Let's say you deployed a pod, the pod is coming up in the worker node 3. You see the pod has a IP 172.31. I given some IP. Yes, definitely pod will have a IP. Inside the pod, yes, there is a container. Yes, the pod is currently listening on port number 80 because that's what the default port my web server. And you see sometime back when I was deploying the pod, I given some labels, right? And keep saying that the labels are just for identification purpose and all. Yes, I'm just specifying the labels as well here. Maybe I deployed a pod with this specific label, whatever I have set it. Then the Kubernetes will go and deploy the pod. It will apply that tagging or labeling. The application is running on the worker node 3. So far, so good. I think this is the pod which is currently running in our environment as well. Similarly, right, you may deploy any application run as a pod, correct? If you have the image, you just say that, hey, this is the image, please run as a container, sorry, as a pod. You just take the image, run the pod, correct? So let's say I'm deploying the one more pod that will come up in any one of the worker node. You deploy a one more pod that may come up in any other worker node, something like this. When you are deploying multiple pods running the multiple different applications, how are you going to identify them? How are you going to know that which pod is running which application? Labels, right? That's the reason I always try to compare with your EC2 servers. Let's say you have some 10 EC2 servers. How do you know which application is running in which EC2 server? In general, the tagging will help you, right? You give the different tagging for each and every server, and you define in the tags how and what is running over there. Just for identification purpose, nothing. So it's very easy to go and look at the tag and see what's the purpose of the EC2 server. Agree? Similarly, even here, when I'm deploying the pod, you ensure you are giving a proper label to the pod. The label will define at least, the label will help us to know which app is running in which pod and all these things. Agree? That's the reason if you see, I deployed 3 pods. Each pod has a different label. That label will help me to identify the pod, what is running inside and other things. So far, so good. Whenever you deploy the port number where the pod is listening, that port is called as a target port from the terminology wise, right? The port that the pod is listening on is called as a target port. In order to access the application from outside world, we need to create a service of type NodePort. Whenever you create a service of NodePort and you see the service, this is called as a service, guys. Whenever you create a service, the service will be get deployed. The service is just a software configuration. The service will be deployed. A service will have a IP address called as a service IP. The service also will be listening on port number 80 or whichever the port number that you define, right? This service, just to understand, the service that I'm deploying in the Kubernetes cluster, this service is acting as like a load balancer. How many of you know the AWS load balancer? How AWS load balancer works, guys? The AWS load balancer will take the traffic from the external world, and the AWS load balancer has multiple EC2 instances as a target. The AWS load balancer will try to decide now the traffic should go to which EC2 server out of it, correct? Of course, there is a target group. I'm not too much worried about the target group now because that is part of the load balancer concept anyway, right? So the load balancer is now routing the traffic to the backend servers, right? If you have multiple servers, it will decide how the traffic should go there, right? And if any one of the server is down, it will know that the server is unhealthy. No, don't send the traffic to that. Correct? That's the basic functionality of a load balancer there. Correct? The same way, the service that I'm creating in the Kubernetes here is exactly working as a load balancer, but this is working within the Kubernetes layer, within the Kubernetes cluster only. So I have a service, the service has a IP, the service is listening on port number. Now to this service, you need to tell that the traffic that it is receiving should be routed to whom out of all the different number of pods that are available running in the cluster, correct? In AWS world, right?
Sir, I have a question here. So you told you have given that target. Sorry, this one selector has HTTP app, right? So will that 80 port will be only applicable to the label that has HTTP app, or is it going to serve for others as well on the worker one and worker two?
That's what I'm trying to, okay? That's what I'm
Okay.
trying to come up now, right? In the AWS world, right, whenever you create a load balancer, you used to tell to load balancer that, right? Hey, these are the servers that are responsible for you to route the traffic, correct? If there are 10 servers, AWS load balancer will not send it to all, right? You will be telling that, hey, these are the servers that you need to route the traffic, correct? Similarly here, to your service of type NodePort at this time, you need to tell the traffic that is coming to the service should be get routed to which ports out of all the ports that are available. How it is? It is through the labeling, correct? Because labels are the one which will be used here for the identification purpose. So to your service, you define a configuration saying that selector, in the selector you define the label or the label key value pair saying that, hey service, app colon http hyphen app, that is the label that is you are responsible to route the traffic. Now this service is going to filter, is going to search for the pods, whichever the pods having the same label. This service is now going to check the entire cluster. When I say entire cluster, this service is going to check in the worker node 1, worker node 2, worker node 3 also. Wherever it find the pod with the matching label, yes, that is my pod. Now that service will start delivering the package to that particular pod only. The traffic routing from this service to the pod will happen only with the label matching. Nothing will be involved here. Nothing is influenced here using the port numbers. You see here, I have 3 ports. All the ports are actually running with port number 80 only, correct? In this example at least. But the labels are differ here, right? So how the service is deciding now the traffic should go to which pod? So the label. So the service is going to search for the pod having the same label, right? Then the service is going to deliver the traffic to that particular pod only. From the terminology wise, the port number that the service is listening on, that port number is called as a port. We call it as a simply port, or we can call it as a service port, because there are number of ports, right? One port is listening at a pod level, one port is listening at a service level. We need to understand the differences. That's the reason the terminologies are getting differ here. But can I send a traffic to the service port directly? Not really, right? Why? The service is also a internal component which is available within the Kubernetes. If we have a user who wanted to access this website from public browser, right? I can't send the request to the service directly, right? Remember the concept previously as well. When your application is running inside a container, you can't reach the container directly, right? Always your traffic will come via EC2 server, right? We talked about that in the Docker world. Always the traffic will come to EC2. The EC2 will have a port mapping concept. Then the traffic will go inside the EC2 or inside the container network level. Same thing here as well. The service is helping here as a load balancer just internally within the Kubernetes only. But how would the traffic will come from outside to the service? That is where every worker node must be listening on a specific port number. That is what I'm referring it as a port mapping now. So here I'm actually doing the port mapping between a service port and the worker node port. I'm doing the port mapping between the service port and the worker node port. Like previously, I was doing the port mapping between the container port and the host port, right? Why? That time my container was running in the one server only. It's very easy to do the port mapping. But now your container may be running in any worker node, right? Possible. So I can't rely on this. That's the reason the Kubernetes has a concept of service. The service will take care of internally, right? And you do the port mapping from the service to the worker node port number. In this case, you see the worker nodes are listening on a port number called 31,000. Can be any port number. I'm just taking 31 for now. The port that the worker node is listening on, that port is called as a node port from the terminology wise. Now, is it easy, guys, to send a traffic to the node port? It's easy, right? Because NodePort is the port that is listening by your EC2 server, right? When my EC2 is able to receive the traffic on so and so port, I know how to send a traffic to my EC2 server, correct? We already familiarized with that. We know how to send a traffic to the EC2 server. So now you send a traffic to the EC2 server port number, which is a node port in this case. Whatever the data that comes to the node port of a worker node, that request will now be sending to the service port because we did the port mapping, right? Here the service port is getting mapped to all the three worker nodes possible. Previously I was doing the port mapping to one host, right? Now you see I'm actually mapping your service port with all the three nodes. Why? It is a cluster. When I say cluster, all the nodes will be involved. Is mean that whenever you do this kind of a port mapping, the request may come to worker node 1 or maybe a worker node 2 or maybe worker node 3. No matter the external user request is coming to which server, the traffic will definitely be routed to the service port. Agree with me? Let's say tomorrow you wanted to access a website. If you send a request to worker node 1 or worker node 2 or worker node 3, the request will come to whom? That will be coming to your service port only. The service is not application. I mean to say from your perspective, it is not application. Service is just a configuration, guys. Because as I see a question in the chat window, right, where the service is running, service is not a no application to consume some processor memory, right? The service is just a configuration, the Kubernetes configuration, right? One service will handle the routing in all the worker nodes. Just a configuration. It's just a software setup, right? Just a Kubernetes feature, whatever you call it as, right? So there is no concept like the service is running in the worker node 1 or worker node 2, worker node 3, or in the control plane. No, that is not that is not applicable at all for now, right? The service is just a configuration. Service is just a load balancer configuration within the Kubernetes cluster, which will take care of doing this whole routing process. Whenever the request come to the worker node, that request will come to service. Now the service will search for the pod having the matched label. When it identify the pod with the same label, then the service will be routing the traffic to that particular worker node. If you look at here, the service, I have put a box covering all the three nodes. Why? Just to tell that the service is not something which will be running on one node or in control plane. No, that is just a configuration that is looking after the entire worker nodes. Getting me? That means one service is now capable to route the traffic to the pod, no matter the pod is running in where. It can be one or in two or in three. Wherever it is running in, it can route the traffic. And it can receive the traffic, right, from any worker node as well, because the mapping is done to all the worker nodes by default. Are we good with this? Why doing all these things? Because see, when I have three worker nodes, your application may run in one worker node or second worker node or third worker node. Tell me guys, whoever is accessing my website from the internet browser, they do really care about your app is running in which worker node? No, right? It can be in any worker node, I don't care. If I go and access my website should come, right? So that's the reason this whole exercise, right? So the request may come to any worker node, should be handled by my service, should be able to route to the backend pods, no matter where it's running. You see now, I'm just using this in order to send my traffic to the worker nodes. http:// you give the worker node IP colon worker node level node port, then you send the traffic. You send a traffic to 1 or 2 or 3, still you are able to get your website. Getting me? Let's say your application is actually running in the worker node 3, right? But still you should be able to access your application from worker node 1 also. Is it clear? You can send a request to worker node 1, still you will get a response, though your application is running in worker node 3. Good with this? That's the reason you don't need to worry about the application is running in which worker node. No matter where it's running, you should be able to access it from any of the worker node. That's how it is working as a cluster, Kubernetes cluster. If I send a request to the worker node 1, how we get the response? The port number 31000 listening at a worker node 1 is having the port mapping to the service, right? Once the traffic reaches to the service, now it's a service responsibility to route the traffic to the backend pod wherever the labels are matching. That is what the service is taking care of now. That's the reason no matter you are requesting the access from any worker node, you should be able to access the application because the service is acting a internal load balancer within the Kubernetes level to make this happen. Because of the criticality in understanding the logic like concepts, right? I made this kind of the presentation on my own, which you don't see in general, right? To or it's typical to understand the concept, guys. Now I don't need to worry about the labels when it comes to the end user. Whoever is accessing my website, right? They will just say that, hey, I want to access a website. You send the request to 31000. You already did this configuration. Anything that comes to 31000 should come to the service. Anything that comes to this service should search for the pod matching the so and so label. So it's a service responsibility to identify the pod matching the label, and you need to tell that upfront how it has to search for. This is something within internal to the Kubernetes. The one who is accessing the website, they will never care about your Kubernetes, your labels, your pods. I'll take another 5 minutes to deploy this because deployment is easy. You just need to understand the backend logicalities. Now, anyway, my pod is currently running, right? So this is good. Now the next step is I need to create a service, correct? So I'll create a file, service.yaml, right? I need to create a service now. So how to create a service, guys? Kubernetes service. I want to use the NodePort service. I need a YAML manifest file for that, right? So this is how you get a example of the manifest. Just take this. It's very easy to understand now. Put that here. Now you see API version. Okay, let me go for second line first. The kind, what kind of the resource that you wanted to create now? I want to create a service, right? So you define that, hey, I want to create a service. Good. Now to create a service, what will be the API version? Is it V1 or something else? That you get it from documentation. The documentation says that to create a service, always your API version is V1. Okay, that line is also done. Under the metadata, this is the name, right? You need to give the name for your service. Any name would be fine, whatever the name that you like it. Now the spec section. This is talking about the specification of the service. What kind of the specification that you are looking for the service, guys, in general now based on the discussion? Like if this is a pod, the pod specification will always be like pod has to be created with which container, which image, right? When it comes to the service, what kind of the specification that you are looking for a service? The service should listen on which port number. The service should route the traffic to which pods in the backend. That's the specification, right? So based on that, we need to fill up this form. At high level, let me give this, right? Under the spec, maintain the indentation and specify the selector component. This is where you need to tell that this particular service should route the traffic to which labeled pods. That's what you need to tell the labeling here. So which labels that you given to the pod at the time of creating a pod, right? Which label that you use here, you give the same label in the service section as well. Then only your service can identify the pod matching this particular label to route the traffic. That's very important, right? Now, under the port section, you define the details. My service has to be listening on port number 80, right? My service has to route the traffic to port number 80 of your backend pod, right? And what else? I think, right? So 31,000 is my port number at my EC2 server level. You need to give all the 3 ports that we are using in this configuration, guys. How many ports that I'm using here? One port at a EC2 server level called as a node port, one port at a service level called as a port, one port at a pod level called as a target port, correct? You need to give all these 3 ports information in the manifest file itself here. That's it. Your manifest file is ready, guys. The target port is obviously the port where the application is listening on. The service port can be anything, but it's better to use same as your target port just to avoid the confusion. When it comes to the node port, Kubernetes has its own requirement. You cannot go and take whatever the node port that you like it. Kubernetes says the node port that you are expecting to listen at a EC2 server level should be definitely within this range only. If you take any other number, it will not work. That is the reason why I'm using 31,000 as an example, because that is within the range that the Kubernetes has defined. If you take any other number, it will not work, guys. That's it. My service is ready. Just matter of kubectl apply -f service.yml file. One thing that we need to specify here, type. So I need to specify that the type is NodePort. I need to tell that the service type is NodePort. Let me get the syntax, guys. Of course, we need to depend on the syntax. NodePort AML. Okay. So the under the spec there is a type, then the NodePort. So this particular line should go under the spec indentation and specify there. That's how it works. Yeah. Always get some example and try to make it happen. What's happened? That's okay. It is saying that N is uppercase. Okay. N should be uppercase. Done. Our service is created. Now let me do kubectl get service. This is the command to see the service. Now you see that the service is created. The service type is NodePort that we are using today. The service has a service IP. You see the port mapping now. Can you relate this to your Docker concept now? The Docker we were able to do the mapping, right? The same concept here as well. But the only extra thing is the EC2 server level port is mapped to the service. Again, the service is having the labeling concept to identify the backend pod because of the multiple worker nodes. I'm done. So I'll go and access this website from my browser. Where is my AWS? Whatever the discussion that I have done, everything is implemented with one single file called service file. this service file will do all the discussion that I have done so far. That's the reason at the time of execution we can't understand a lot of things, right? We need to see it as a presentation only. So I'll just try to access my application so that we will be good for today. Yes, when it comes to here, right? Sorry. Whenever you say that, hey, 31,000 is the port at a worker node level for this particular service, it automatically take care of mapping this port in all the worker nodes. We don't need to tell that this is the port in every node. No, it's a default. That means all the worker nodes will start listening on 31. Any worker node that receives the traffic at 31,000, it will be given to this service. That's how it's configured, right? So I'll just go to one of the server. I'll just take one server, take the IP address. Now, possibly you may need to allow the security group rule to allow the traffic. Which port that I need to allow here, guys? 31,000, right? That's what the servers are listening the traffic, correct? Not 80. 31,000 is the port that the EC2 server is listening on, right? You specify the 31,000 there. Now let me get the IP. Take one of the EC2 server IP, go to the browser, IP address colon 31,000. Your website is working. Now you take the second server. You take the second server IP. This is my second server IP. Go to the browser, IP address colon 31,000. Why it's not coming? Did I not
I think
allow
there
the
is
port
another
number?
security group here. No,
It
there are
should
two security groups, I think.
it should be allowed. Let me specify 31,000 there. Anywhere. Save the rule. It's working. So what happened again? Right? So where my pod is running, guys, if I look at once, kubectl get pods -o void. Your pod is actually running in the worker node ending with the 226, right? It's running in one server, but this application is now accessible on both nodes. The request may go to any worker node, your application will run. How it's happening? Again, this is the concept, right? The request may come to any server that will be given to your service. In the service, I already configured that, hey, if you get anything, you please give it to so and so pod based on the label that you identify. And your pod will receive the request. Inside the pod, the container is there. Container will receive the request. Application is there that will be sending the response. The same response will be given back to the user, whoever is requesting the access, the website. So in this case, the 31,000 is blocked. That means the 31,000 is now dedicated for this particular service only. This service is dedicated for this particular pod only, whichever the label that you specified. If you have another application that you wanted to access, it should be having its own service, should be having its own port number at a node level. Same as previously also, once you do the port mapping, right, you can't use the same port number for other mappings, correct? Same thing here as well. Now the 31,000 is mapped for a specific service that is routing the traffic to specific pod of the same map label. So if you have any other application, you try to create a one more service, one more different port number. Then that's how it works so far. We can do some improvements later anyway. That's the story for today.
Sir, one question. So, how is it opening it in the other EC2 as well? So, you opened it in two, right? 173 and one, the other one.
Okay.
So, this is mapped to go to only one worker node, right? So that has HTTP app. So, the other one, the other worker node also is labeled as HTTP app. Maybe I got confused here. So,
Now tell me, in this presentation, my application is running is where? In where?
I think on worker node 3.
I don't care one or two or three. This is a Kubernetes. So my answer is always my application is running in a pod in my Kubernetes cluster. Getting me? So
Yes.
Kubernetes will never worry the app is running in one or two or three or four. Kubernetes will never care the service or the application or a pod in which worker node. Whenever the request comes to the worker node from outside, that request will be forwarded to the service, NodePort service in this case. That service will just search for all the worker nodes. That service is going to search in all the worker nodes where my pod is running, matching the same label. Once it identify the pod, it will be routing the traffic to that particular pod. It's not caring about the worker nodes in this case. Getting me?
Okay.
Right? So that's the reason we will never worry about the pod is in one or two or three. My answer is always my pod is running in my Kubernetes cluster. The request can be routed to the pod. That's it. No matter where it's running. That's the whole idea, right? That's the reason tomorrow if the one worker node 1 is down, no impact. Even now, let's say the worker node 3 is down, no impact. Your pod will just come up in the another worker node because from the Kubernetes perspective, it doesn't care where it's running. It can be running in anywhere. It can simply route the traffic. It's all care about the labels here. As long as you are maintaining the labels properly at a pod level, at a service level, it can identify the pod, can route the traffic. Yes, please.
If we have one more pod, like in all the three worker nodes running the other application, so the port number for them will be 80, and for the NodePort service, it will be of different IP, so we can have 80 as a port number for that event too. The only thing which changes is 31,000, right?
Correct.
Okay. And one more small doubt. Here we are treating NodePort service as a load balancer. Like we are just comparing with a load balancer which we already learned, or it's actually behaving as a load balancer. Because in the load balancer concept which we have learned before, under load balancer we had two target groups where both were identical. It was routing the traffic to share the load between two of them, but here it's different case.
Okay. What is load balancer? Load balancer is the concept of receiving the traffic and routing the traffic to the backend. That is called as a load balancer. Forget about target group, forget about EC2, forget about any other, right? The load balancer meaning that it takes the traffic and identify the backend target whoever want to receive this, and it will be forwarded to them. That is called as a load balancer, right? There are hundreds of different load balancers who will do the same job in a different ways, right? AWS load balancer may have a target groups to make the things happen. Another load balancer may have a different approach. Another load balancer may have a different approach. Getting me? So when I say load balancer, is not mean that every load balancer will have a target group. No, every load balancer will have the same concept. No, the load balancer is mean that the basic principle of a load balancer is to get the traffic, try to forward the traffic to the backend, right? Whoever is responsible for that to receive. That's it. That's why I compared it. But this is not doing the whole load balancer capabilities. No, it is just a simple load balancing concept, right? Which will be taking the traffic and see the traffic has to go to which pod, identify the pod using label and send it to them. That's it, right? And again, I use the term called load balancer so that it's easy to understand that it is doing the routing job here. But Kubernetes will never say that this is a load balancer. Kubernetes always says that I have a I have a service which is responsible to discover the pods which the whichever the pods that the traffic can receive using the label concept, and that's what the terms that the Kubernetes is using.
Okay. So if we want to keep this under a load balancer, like which we have done before, like the same functionality, so we need to put all these 3 worker nodes in one target group and the similar one in another target group, and then assign it to the load balancer.
Don't worry about AWS load balancer for now.
Okay. Like, do we be going through that in further classes, like
Yes,
relating to that? Okay.
of course we need to do that, because no one will send the traffic to the worker node directly, right? Because the end user will never care about worker node 1 or 2 or 3. I just need a website. As a www.edουeki.com, I just need a website, right? How that happens? We are going to integrate to AWS, but we'll see how that works later. For now, if the request comes to one of the worker node, how that is handling within the Kubernetes, that is what is the focus. We'll try to integrate with the AWS load balancer later.
Like if we want to compare with auto scaling as of now, like as we have seen it before, like yesterday or day before yesterday.
We can't compare with auto scaling because so far I did not talk about anything related to the auto scaling features,
Okay.
because
Oh,
there is no scaling concept that I talked about in the today lecture.
okay, Pia. Thank you so much. Like as of today, it's good. Yeah.
Right? So answering to the question that I see in the chat window, always you first create a pod, then you create a service. You can't create both together at one go, right? Though you try to, Kubernetes will create a pod first, then it will create a service next. That's the sequence. Why? When you are creating a service, you are telling that the service has to route the traffic to so and so, right? Correct. So that should be there already, from at least from the concept wise, right? From the concept wise, the pod should be deployed first, service has to be deployed later. Then the service will know that the traffic should go to whom, correct? But if you try to create vice versa, right, it will be done, it will be creating, not a worry. But from the concept wise, you create a pod first, then the service next. Yeah, that's how the Kubernetes is making things mad sometimes. Any questions, do let me know, guys, or else we're good for today, and we'll catch up in next lecture.
I have one more small doubt, Pia. Like here, if we see the labels, it is like login, HTTP and one is database. Like if we compare it with the real time, if we log into the edwiki.com and one tab will be login and one tab will be the other thing, it like the similar kind of thing, like we go into one DNS and then we go into different services.
Yes, possible. Yes, we do that.
Okay, so at the back end, it's only the one request. So the NodePort service will take care of label, and then it will be like routing the traffic.
Of course, but your NodePort will have only one label, and it can route the traffic to one set of pods matching. Not like it can one NodePort cannot send to DB app login. No, it will not work like that. So
Okay.
it's a different concept altogether. We'll come to that later. It will not work like this. Okay,
Okay.
here I said the different labels here just to show you that if you have multiple pods, your service, your NodePort service, right? Your service will identify the pod whichever is having the matched label. That's it. In this case, right, the HTTP service will have its own service. Sorry, HTTP pod will have its own service. Login app should have its own service. The DB app should have its own service. Every pod, I mean to say, every service should have, again, to not to confuse, when it's a service application, maybe application is the right term, right? Every application will have their own dedicated service to be deployed for routing purpose. One service, one Kubernetes service cannot take care of routing the traffic to all the different type of service, different type of applications. No,
Yeah, I get it. All of three are the different
correct. You should be having three
applications.
services now. Here, to access these three applications, right? You should be having three services.
Okay.
One service having the selector to route the traffic to HTTPD, one service having the selector to route the traffic to login, one service to route the traffic to DB. You should be having three services. Each service should be mapped to three node ports. That's how it works.
Okay. The whole concept of this one is like from one worker node we can access in the other application.
Yes.
Okay. Okay. Thank you, Pierre. Thank
The
you so
whole
much.
concept is there are two things. One, the request may come to any worker node. You can access the application without worrying about the application is running in which worker node. Second, your service is taking the responsibility of routing the traffic from whatever is coming from external to the pod by using the labels that it is trying to match for. And each application should have a unique label. That is your responsibility to take care of that. You should not make it duplicated, right? Right, which application is running in which pod. So each application should have its own unique labels. Then only you can make this routing easier. Right. So the terminology is little important. Why would the worker nodes have the information about the services? Kubernetes will have the information about the services, right? So at the end of the day, who is managing all this? Kubernetes, right? API server is keeping all the information in the etcd database. The etcd database will have the details about the number of pods, number of services, the service type, the service port number, the number of worker nodes, whatnot. Everything is there in the etcd database. Your API server will go and read the information, will manage the whole stuff. Any questions, guys?
Sir, one question, shall I?
Yes, please.
Sir, the selector app HTTP and an app, we have connected these two, right? In service file, we have connected these two, right? Worker 3 and selector file. We have written a service file, right?
Yeah, again, doesn't
If
matter
this,
worker 3 or something else. I just said that in the definition. Hey, this is a service that I'm deploying. This service should listen on port number 80. This service is port mapping to 31,000 at a worker node side. Any traffic that comes to should be sending to port number 80 of my pod. Which pod? Select the pod whichever is having this particular label. That is the whole understanding of this file.
um, once, can you open this diagram, sir? In these labels HTTP-AP, once this goes down, the other two labels are getting deferred, right? Then how can these worker 3 will be coming up again if that goes down?
Which goes down? Worker 3.
Worker 3, yes.
Mm-hmm. So yeah, we have these scenarios tomorrow probably. If worker 3 is down, okay, if worker 3 is down, your application will come in another worker node. Kubernetes will take care of that, right? If worker 3 is down, if this node is down for any reason, the pod that is running in the worker node 3 now will come in another node. Maybe it is coming in worker node 1. Now you see your service will now route the traffic to your pod. Your problem is solved.
It will be replicated internally within
It's
the
not
pod.
replicated. It's not replicated from the terminology wise. It's like uh, moving the pod from the failure worker node to the healthy worker node. The moment when the pod is moved to the different worker node, your service, right? The service responsibility is always searching for the pod wherever the label is matching, right?
Yes, yes.
Immediately it identifies that, oh, I have the pod here. Okay, let me route the traffic to that pod. Your problem is solved. Your access is granted. No matter the if the worker node 3 is down, still you don't have any issue,
Okay. Yeah, got it. Thank you.
right? Yeah, we'll see further enhancements tomorrow that will give you more clarity how the traffic flow is working, guys. Thank you. That makes sometimes interesting as well. All right. So if no questions, we'll catch up tomorrow. I mean to say in the next lecture. Thank you.
So when is the next class? On Sunday.
Monday IST or Sunday EST. Thank you.